look at this triangle. When we see this sign at the corner, it describes an angle of 90 degrees, which is also known as right angle, and therefore this triangle is called as right angle triangle. We also know the fact that in a triangle, the measure of all the three angles is equal to 180 degrees. So, measure of one angle is 90 degrees clearly means that the sum of remaining two angles should be 90 degrees. And when the sum of these two angles is equal to 90 degrees, they actually complete a triangle. And so they are called as complementary angles. So, when the measure of one angle is say 10 degrees, other will be 80 degrees. When one angle is of 25 degrees, other will be 65 degrees, and so on. In trigonometry, we have some special angles: 0 degrees, 30, 45, 60 and 90 degrees. These pair of angles are called complementary angles. Now, if we talk about the sides, we know that the longest side in a right angle triangle, which is opposite to 90 degrees angle, is always known as hypotenuse, and the other two sides are defined as opposite side and adjacent side. But which side is opposite side and which side is adjacent side is all depends on from which angle you look at it. So if I look at from say 30 degrees angle, then I know that the side which is opposite to 30 degrees called as opposite side, and the side which is adjacent to 30 degrees is called as adjacent side. Now, if I view the same sides from 60 degrees angle, then this side is the opposite side and this side is called as adjacent side. And please remember, hypotenuse will remain same and it does not change at all. So now we are aware of sides and angles, and in our previous session we have also learned the relation between the sides and angles in trigonometry, which is also known as trigonometric ratios. And today we are going to learn the relation between the trigonometric ratios of complementary angles. So let us first give some values to these three sides as A, B and C. So if I first consider 30 degrees angle, then I know that sine is the ratio of opposite side to hypotenuse, and therefore sine 30 will be equal to B upon C, because B is opposite side and C is the hypotenuse for 30 degrees angle. Now, if you look at side of length B from 60 degrees angle, the same side B is the adjacent side for 60 degrees, and as we know, C, which is the hypotenuse, is same for all the angles. And we also know that the ratio adjacent to hypotenuse deals with cos. So we can see the value of sine 30 is exactly same as the value of cos 60. And note that in the very same way, if we take cos for angle 30 degrees, then cos 30 will be equal to the ratio adjacent side to hypotenuse, and adjacent side of 30 degrees angle is A, and therefore the ratio will become A upon C. And for 60 degrees angle, since A is the opposite side, so A upon C will become now sine for the angle 60 degrees, and therefore we can see even the value of cos 30 is same as sine 60. So what do we understand from this? We understand that sine of one angle is same as the cosine of its complement and vice versa. In fact, the value of sine will always be equal to the value of cos for any two angles which add up to 90 degrees. Now let me ask you a question. What will be the value of theta for which the expression sin theta is equal to cos 40? It is 50, because 50 plus 40 will give us 90, and therefore sin 50 will be equal to cos 40. And we know that, as mentioned in our previous session, we have predefined values for these specific angles 0, 30, 45, 60 and 90, which we frequently use in trigonometry. So looking at the table, we can see the value of sin 30 is defined as 1 upon 2, and therefore we can see cos 60 degrees is also equal to 1 upon 2. And again, as 0 and 90 are complementary angles, the value of sin 0 is same as the value of cos 90, and that is equal to 0. And similarly we can see the value of sin 45 is same as the value of cos 45, and that is equal to 1 upon root 2, and so on. Now we also know the fact that when we reverse the sine ratio, we get cosec, and when we reverse cos ratio, we get sec. So what do you think? As sine and cos are same for its complementary angles, can cosec and sec be also same for its complementary angles? So let's check. So we know that cosec 30 is the ratio of hypotenuse to opposite side, and from this triangle, which is same as the ratio C upon B. So again I view the same sides C and B from 60 degrees angle. C will remain the same, that is hypotenuse, but B will be the adjacent side for 60 degrees angle, and therefore we get the ratio hypotenuse to adjacent side for 60 degrees angle, and which is nothing but the sec ratio, that is sec 60 degrees. So again the value of cosec 30 is same as the value of sec 60 degrees. And similarly we can see that the value of cosec 0 and sec 90 is same, because 0 and 90 are the complementary angles, and cosec 45 is same as sec 45 and vice versa. So far we have seen that the value of sine is same as cos, and the value of sec is equal to cosec for any two angles whose sum is 90 degrees. So in the very same way, if I write for tan, which is the ratio of opposite side to adjacent side, and that is equal to the ratio B upon A. So since B is adjacent and A is opposite for 60 degrees angle, and adjacent to opposite always deals with cot, and therefore we get tan 30 is equal to cot 60. And again if I cross check with this table, the value of tan 30 is equal to 1 upon root 3, which is same as the value for cot 60. And similarly you can check the value of tan 0 is also same as the value of cot 90, and so on. So let me tell you one very important point from the things that we have learnt so far. Sine and cosec are inverse of each other, but they can't be complementary. Cos and sec are inverse of each other, but again they are not complementary. But in case of tan and cot, they are inverse as well as they are complementary to each other. So that's all for now. Let's revise. So don't miss out our next session of trigonometry, because there we'll learn a trick to remember this table and also the logic behind it.